Have you ever lain on your back on a summer's day, gazing up at those big, fluffy, cotton wool clouds drifting lazily across the sky? They look so light, so airy, so utterly weightless. You might imagine you could reach up and scoop one into a jar, and it would weigh no more than a handful of feathers. It's a lovely thought, isn't it? But what if I told you that the average cumulus cloud weighs about the same as 100 elephants? It seems utterly preposterous, a notion so absurd it borders on the comical. How can something so colossal, so unbelievably heavy, simply hang there in the blue expanse above us without a care in the world? This is one of those wonderful little paradoxes of science that is both baffling and brilliant. Our eyes tell us one thing, that clouds are ethereal wisps of nothingness. But the unyielding laws of physics tell us something entirely different. And to do that, we need to start right down here on the ground. Every puddle, every lake, every river, and every vast ocean, the sun shines down, warming the surface of the water. Water molecules gain energy and jolt. Some break free and float up as invisible water vapor. This process is called evaporation. It happens all the time, lifting trillions of gallons into the atmosphere. The vapor is light and rises, mixing with warm air. As the warm, moist air ascends, it cools. Higher in the troposphere gets chillier. Cold air holds less water vapor than warm air. When it cools enough, it reaches the dew point. The air becomes saturated and the vapor must condense. Condensation is gas turning back into liquid, but vapor needs something to cling to, a tiny solid nucleus. Think of it as a microscopic dance floor for droplets. Those particles are everywhere. Billions of these droplets together become a visible cloud. So we've established that a cloud is made of countless tiny water droplets. Individually, each droplet weighs next to nothing. But when you have an astronomical number of them gathered together, the weight starts to add up. And it adds up in a very big way. Scientists can't exactly pop a cloud on a giant set of bathroom scales, of course. So they have to get clever and use a bit of mathematics. First, they measure the size of the cloud. A typical, friendly-looking cumulus cloud might be about 1 kilometer long, 1 kilometer wide, 1 kilometer tall. That gives it a volume of 1 billion cubic meters. Next, scientists figure out the density of the water inside. They fly specially equipped aircraft through clouds to measure liquid water per cubic meter. A fairly standard value is about 0.5 gram per cubic meter. 0.5 gram doesn't sound like much. It's the weight of a small paperclip. Now the crucial multiplication, 1 billion cubic meters, x 0.5 g per cubic meter, equals 500 million grams. Convert that, 500 million grams equals 500,000 kilograms equals 500 metric tons. That's roughly the weight of a fully loaded jumbo jet, or about 100 large elephants. We arrive now at the heart of the matter. If a cloud weighs 500 tons, why doesn't it come crashing down on our heads like a 100-elephant pileup? The answer is twofold. Density, updrafts. First, let's consider density. The total weight of the water in the cloud is immense, but it's spread out over an immense volume. That 1 billion cubic meter cloud has 500 tons of water, and all the air in that volume too. So the cloud as a whole is far less dense than you might think. The crucial comparison is density relative to the surrounding air, not weight in a vacuum. The air that makes up the cloud, warm, moist air, is warmer and less dense than the cooler, dry air around it. Think of a hot air balloon. Heated air inside is less dense than the air outside, so it rises. A cloud works in much the same way. However, the individual water droplets are much denser than air. So why don't they just fall? This is where the second part comes in. Updrafts. A cloud is not static. It's a dynamic, churning environment. It's like a juggler keeping multiple balls in the air. For instance, clouds aren't just a feature of Earth. Mars has clouds made of water ice. The gas giants, Jupiter and Saturn, have spectacular, planet-girdling bands of clouds. Venus is perpetually shrouded in thick clouds of sulfuric acid. Suddenly, our own fluffy water clouds seem rather tame and friendly by comparison. Here on Earth, clouds play a vital role in regulating our planet's temperature, acting like a global thermostat. Their white tops are brilliant at reflecting sunlight back into space. This has a cooling effect. This is called albedo. Have you ever seen a cloud with rainbow-like colors? These are called iridescent clouds. Another fascinating type is the noctilucent or night-shining cloud. These are the highest clouds in our atmosphere, forming over 50 miles up. So, the next time you look up, don't just see a cloud. See it for what it is, a magnificent high-altitude balancing act. See the 100 elephants, see the jumbo jet, see the billion cubic meters of air, see the countless water droplets on their epic journey, clinging to specks of cosmic dust. It is a visible manifestation of the immense, silent, and ceaseless movement of energy and water around our planet.